Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3492 Database Management System. The unit is Implementation Techniques. The topic is Indexing and B+TREE. Indexed file organization. Indexing mechanism used to speed up access to desired data. For example, author catalog in library. Next one is the search key. The search key used in the index file organization. That means it is an attribute to set of attributes used to look up records in a file. This is the structure of the index file. Index files are typically much smaller than the original file. The index file consists of records. That means search key. Records in the format. First one is the search key, then second one is a pointer. There are two basic kinds of indices. First one is the order indices, then second one is the hash indices. Order indices means search keys are stored in the sorted order. Hash indices mean the search keys are distributed uniformly across the buckets, and by using the hash function the values are determined. Next one is the primary index. In an ordered index, the index values are sorted in the search array. The primary index is one of the sequential ordered file. The index whose search key specifies the sequential order of the file. Secondary index means an index whose search key specifies an order different from the sequential order of the file. It contains two indexes, dense index and sparse index. Dense index means index record appears for every search key value in the file. The first one is the example for dense key. That means index record is the first figure shows the dense index. That means here the first record details are available. Then from that means first the data, then after that the pointer. The pointer, first one is the search key, then second one is a pointer. The pointer shows the particular data is present in which place. That means it represents the, for example, in the Brighton. Brighton means that represents the A217. Here the particular T. And the Brighton is one of the search key used for the particular record. The next one is a pointer. Like this is the dense index. Sparse index means it contains a record for only some search key values. That means in the sparse index, to locate a record with a search key value k, so find index record with the largest search key value. Here only 3 search key values are used. That is the difference between the dense and sparse. Dense means the search key is for all the record, but in the sparse index the search key only for some of the records. Next one is the multi-level index. Multi-level index means if the primary index does not fit in the memory, so access becomes expensive. To reduce the number of disk accesses to index record, treat primary index keep on the disk as a sequential file and construct a sparse index on it. Here there are two indexes are used. One is the outer index, then second one is the inner index. Outer index means a sparse index of the primary index. Inner index means the primary index file. If even outer index is too large to fit in main memory, yet another level of index can be created, and so on. This is the structure of the multi-level. First outer index, from the outer index inner index are formed. From the inner index the data blocks are arranged. Like this the multi-level index are formed. Next one is the B+ file organization. B+ file organization is the advanced method of indexed sequential search access method. It uses tree-like structure to store records in the files. It uses the same concept of key index, where the primary key is used to sort the record. For each primary memory, the value of the index is generated and mapped with the record. The B+ tree is similar to the binary search tree. but it can have more than 2 children. In this method, all the records are stored only at the leaf node. Intermediate nodes act as a pointer to the leaf node. They does not contain any records. This is the structure of the B+tree. Like this B+tree index value. Here the B+tree index value, the node level is n equal to 3. And this is a structure. Next, advantage of B+tree. The advantage of the B+ index tree file is automatically reorganizes itself with small local changes in the phase of insertion or deletion. Reorganization of entire file will not require to maintain the performance. But the disadvantage of the file B+tree is extra insertion and deletion overhead, space overhead. A B+tree is a rooted tree satisfying the following properties. That means all paths from root to leaf are the same length. Each node that is not a root at a leaf has between n/2 and n children. For some special cases, if a root is not a leaf, it has 2 children. If the root is a leaf, it can have between 0 and n-1 values. Next one is the B+tree node structure. First one is the P1, that means pointer. P are the pointers, K are the search key values. P are the pointers to children and pointers to records or buckets of record. These are represented in the particular P1 value. Next, K1 to Kn values are the search key in a node are ordered in the K1 to Kn-1. Suppose if it is a pointers Pn means, then the search key values are Kn-1. This is an example. This is the example for before and after insertion of. First one is the first figure shows them one B+tree. In this one new values, that is the clear view is inserted in the particular tree. After the next second figure shows them after insertion of the clear view. Next, update. Suppose any updates or makeover on the B+tree means, that is deletions. Find the record to be deleted. What content to be deleted is first find and remove it from the main file and from the bucket. Remove from the leaf node if there is no bucket or if the bucket has become empty. Then if the node has too few entries due to removal, then the particular entries are in the node and sibling fit into the single node. Then insert all the search key values in the 2 nodes and in a single node and delete the other node. This is the B-tree file organization. B-tree file organization is arranged in this way. First one is a pointer, then second one is a search key value. The first pointer denotes what are the contents are before the particular I value that are available in this way. Next, right side of the pointer, I pointer, after the I pointer denotes what are the contents are after the I that are available in the particular pointer.